Hello everyone and welcome back to the channel. We're back here in the trusty corner with New York and San Francisco. So I hope you like that. It's a little bit of change of scenery from the last videos. Anyways, we haven't done an update on the Ben Eater computer I've been building in a long time. And at the end of this video I'm going to go over what my end goal for this computer is going to be. Because I don't want to just stop it at building the CPU. I want this computer to have a goal, and it's going to be pretty cool. So stick around if you want to find out how that works. Anyways, today we finished, well, it's been a long time, but I finished the registers and the ALU, so the Arithmetic Logic Unit. So the computer can now do math, kind of. And it's kind of tedious because you have to input each bit by yourself by moving jumper wires around. But it works, and this is what it looks like. Okay, so if we can get this on here. I know it looks like a mess, but it's the best I could do, okay? It functions is the amazing thing. I know it looks like I've got wires running all over here. This is probably the neatest section I did, but over here it got a little wild, a little crumpled. But anyways, it's all working. And so this is the clock module that we built last time, and it's hooked up here. So this cable is connecting this system to the clock, and this white wire connects this register. So this is the B register and the A register. So they're going to store data. And when we tell them to add, they're automatically going to add themselves into whatever is shown here. So these are, this is an 8-bit adder because there's 4-bit and 4-bit, and we tie them together. And then this is the same chip right here and here that allows us to interface with our bus right now. So this is what would be on the bus. And the bus is how the CPU communicates with other modules. So this is like the arithmetic module, which does all the math and stuff, and then it'll output whatever math it does back onto the bus so that another part of the computer can use it. And this is a temporary spot for the clock. It's not going to be here always, but just so it was close to hook them up. So let's see what happens. I think it's in manual mode right now. We switch this switch. So yeah, it's pulsing now. And it read in data because there was already data in here. We can fix that though. But I'm going to change it back from to manual. Alright, so as you can see in the A register, we have a 15, which is the first bit is a 1, second's a 2, the third is 4, and the fourth bit is 8. So 4 plus 8 is 12, and then plus 3 is 15. So that number is 15, and since there's nothing in the B register, when you add those together, oops, I screwed those up. These LEDs are kind of all jammed in here. But when you add 0 and 15, you should get 15, and that's what it's showing right there. But what happens if we change this from 0 to 15 as well? So to do that, we actually have to take these control lines like this, and these are all going to be connected to the control unit of the computer when we're done. But for right now, they're not, so we have to move them manually. Anyways, this is the one that controls what we're outputting on the bus. So when we move this here, we should output what's in here onto the bus. So that's 15 right there too. And then we need to take this and put it into this register. So what we need to do is we need to read from the bus on this register. And that's this yellow wire right here. So we need to take that low because these are inverted. Can I get it in there? Maybe? There we go. Alright, so now it's not reading yet because we haven't pulsed the clock. And when we pulse the clock, 15 should go into that register. Alright, it did, and it automatically added those two together, and this is 30. So, what we do is we take 15 plus 15, and then we get 30 here, and that's correct, so everything seems to be good. So, by moving these jumpers around, I can input stuff onto the bus, and I put a 2 on the bus, so that would just be this second bit lit up. And I already loaded it into the B register, but now we need to load it into the A register, so what we're going to do is we're going to take the load. What line is that? That's here. And we got to take it low, again, because they're inverted. This one's stubborn. I'm going to load it in that 2. We get a 2 and a 2, and that should be 4. So that's 1, 2, and then the 4-bit is lit up. So that is 4, and that means it's working. And so now after the famous 2 plus 2 equals 4, you must be thinking, this computer can't do anything more, can it? Well, technically, it can. See this little wire right here? If we take this out, it can do subtraction. So 2 minus 2 should equal 0, and that's what it shows. But let's do something more complicated. What if we did, let's see, 6? Here, gotta plug this back in so it works. So we're adding again, but we want to get a 6 into this register. So what we're going to have to do is program these bytes out here to be a 6. So that means we're going to have this second bit glowing and the third bit glowing, because that's 2 plus 4 equals 6. And we'll put that into the A register. So let's do that. All you actually have to do is just remove this one wire. And then we need to turn the read on for here. So that's this pin again. Take it low. And I think it's in there. And then pulse the clock. Alright, so that's 6. Now 6 plus 4. Oh, guess what? I made a mistake. The read was on over here, so it read it into this one too. So now we have 6 plus 6 equals 12, which we actually want one of these to be 2. So we're going to have to go back. We already took this. Take this back high, so we'll just read the 2 back into this one. And then we're going to have to plug this wire back in. See, this is the problem with troubleshooting these things. They're kind of hard to plug in. That's the 2. We don't want that. And now we need to make sure that this is off, because we don't want to read in anymore. So we're going to put that high. We're not outputting, but we want to read on this one, so we're going to have to take this low again. And, alright. See if it happens. Okay, so it worked. We have a 2 in here, and a 6 in here. And let's see, 6 plus 4 equals 8, because the fourth bit is 8, so it worked. But now we need to see what it happens when it's 6 minus 2, which should equal 4, but let's see if it can do it. Well, let's see if it can do it. It's a baby computer. Let's see. Alright, it's a miracle. It did it. So the third bit is 4, so that is technically correct. And we have 6 minus 2 equals 4. So the Arithmetic Logic Unit is working, and we'll be back with an update later. But right now, let's talk about the plans for the future. The future of this computer, I want it to be able to run Pong, similar to what we were showing here. Something like that, at least. And I hope we can do this. I'm going to try really hard to do it. I think the clock speed is just about right where we want it for this, and we can accomplish it. It's doable. Anyway, so I want it to be configured like this. So this is going to be a screen on top of this tower, and in the tower we're going to have slots. And so in each of the slots, going to get my trusty scissor pointers here. These are scissors. And in each slot we're going to have different cards. So I think the top one's going to be the video card to interface with the obvious screen, because video and screen, same thing. Anyways, so it'll be closest to the screen so it can interface there. And this will be the CPU. So these will just slide in like boards. And the CPU will connect with all different boards and kind of control them. So that's what the Ben Eater CPU is for. And we're going to use each of the other slots for different things. Maybe a sound card, some storage. Maybe if we go really far is to try and hook some external storage device up to this, like a floppy disk or a USB drive. We could all do that. It's very possible. It's just going to be really hard. Anyways, I'm up for the challenge, so we're going to try. But what I want to do is make this very visible. So the computer is going to have LEDs all over, like in this one. I want to stick with the Ben Eater idea and have discrete logic chips and just basically, not discrete, but like, just build it out of these chips and stuff and have LEDs showing you what's going on in the computer. So it's very easy to learn about and see what's going on inside the computer. So throughout the computer, we're going to have, every card's going to have lights, and there's going to be doors on the side that open up to show you what's going on and exactly what data is being transferred around. So that's what I want it to be like, and I hope you stick around and see the finished product eventually. As you can see, we're not very far. We're only on the Arithmetic Logic Unit, but we're getting there. It's close. We have a clock module and ALU, and we're almost there. Not really, but we're trying. Thanks for watching, and I hope to see you back here soon.